This is Advanced Math, Unit 9, Lesson 5. Descartes' rule of signs. Descartes' rule of signs and upper and lower bounds. Upper and lower bound. Okay. Part 1, these notes are a bit meaty. There's a lot of definitions and type of stuff that we're going to be writing down. Descartes' rule of signs. All right, when we talked on a previous lesson, I talked about we were going to learn tools and how to make some of the guessing go by a little faster. Descartes' rule of signs is one of those tools. Okay, so what Descartes' rule of signs allows us to do is find the number of possible positive, negative, or imaginary solutions. Okay, so here is how it works. Now, initially when I'm writing this stuff down, you may be wondering well, what the heck is she talking about? It's not making sense. Let's just write it down, get it out of the way, and then as we do examples, I'm hoping it'll make more sense. Okay. How do you find the number of possible positive roots? The number of possible positive roots. There's a method to it. Mathematicians before us have figured all this out. So right now we're looking at positive roots. Okay, so what you do is you use your original function. Use f of x or g of x or h of x, whatever it is. Use your original function and look for the number of sign changes. Okay, so I'm just going to pop this up really quick. This was just an old set of notes. So really quick, the number of sign changes here, from positive to positive, that's not a sign change, so none. Positive to negative is one sign change, and from a negative to a positive is two. So this function would have two sign changes. None, one, two. We'll talk about what that means a little bit later, but that's what sign changes is talking about. That's one, none, none, none. So this one has just one because it went from positive to negative and it stayed negative from then on out, so it would just be one sign change. Okay, so number of possible positive roots, we use f of x and look for the number of sign changes. Number of possible negative roots. Now, instead of using the original function f of x, we use f of negative x. We plug negative x into all of the x's, and then we do the same as before. And look for the number of sign changes. Okay. Example. List the number of possible positive, negative, and imaginary solutions. list the number of possible positive, negative, and imaginary solutions. Okay. Number 1, f of x equals 3x to the third minus 5x squared plus 6x minus 4. F of x equals 3x cubed minus 5x squared plus 6x minus 4. Okay. I'm going to leave some space here to do my f of negative x. I'm just going to move down here a little bit. I'm going to write down positive, negative, and I'm just abbreviating here, and imaginary. Number of possible positive solutions, negative solutions, and imaginary solutions. All right, so positive, we look at the original set. Positive to negative, that's 1. Negative to positive, that's another. Positive to negative, that's a third. 3 sign changes. All right, and then I do f of negative x. 3 negative x to the third minus 5 negative x squared plus 6 negative x minus 4. I just put negative x's in for all of my x's. This is going to become negative 3x cubed. This will be negative 5x squared, because that's a negative is gone with the squared, minus 6x minus 4. It stayed negative all the way through, so if the signs stay the same, there is 0 sign changes. All right, I didn't go over up here how to do imaginary, so I'm going to explain that now. Before I do, I want you to make sure you understand here there's going to be more possibilities. You will always minus 2 on both the positive and the negative until you get to 0 or 1. You never go into the negative side. So you're going to minus, or you're going to decrease by 2. So what's 3 take away 2? 1. 1 take away 2 gets me into the negative side, so I'm not going to do that. 0 take away 2, same thing here. 0 take away 2 is negative, so I'm not going to do it. All right, so this is what I started with. And on, say this was a 4, I'm going to quickly just put this up here. If this negative had been 4 sign changes, 4 minus 2 is 2, 2 minus 2 is 0, and that's as small as I could get, because 0 minus 2 is negative. So whatever your starting number is, you decrease by 2 until you get to 1 or 0. 0 is already 0, so I'm not going to decrease by 2. All right. Now, what you do is you look at your degree of your original function. The degree is 3, which means I'm going to have a total of 3 solutions. Some might be positive, some might be negative, some might be imaginary. We do not know the combination, so we're going to figure that out now. So what I do is I'm going to cover that 1. If I have 3 positive and none negative, how many imaginary solutions would I have? None. Why is that? Because if I have 3 positive, they're all 3 of my solutions, degree is 3, all 3 of my solutions are positive. That means none can be negative and none can be imaginary. That's my first scenario. The second one is the 1. If only 1 is positive, and 0 is going to stay 0, that's not changing. 1 is positive and none is negative, how many more solutions do I need? 2 more, because 1 plus 0 plus 2 is 3. I know that sounds kind of confusing, so I will explain again. these should always be even. You don't do any decreasing or increasing. It's just if you end up with a number down here that's 3 or 5 or 7, you've done something wrong. Okay, so what this means is, I'll put that over here, degree is 3. If you're looking at, I'm just going to do it like this, positive, negative, imaginary. One scenario is all 3 are positive, none are negative, and none are imaginary. That came from the 3. 3 positive, none are negative, and none are imaginary. Okay, possible positive solutions could be 1. So 1 is positive, 0 staying 0, none are negative, 1 plus 0 plus 2, because these have to add up to 3 because the degree is 3, which means I have a total of 3 solutions. So these are our 2 scenarios. All 3 are positive, none are negative, and none are imaginary, or 1 is positive, none is negative, and 2 are imaginary. Those are the only 2 possible scenarios, situations we're going to end up with. Why does this help? You're thinking like, why are we doing this? It's really nice that in a situation like this, when you end up with no positive or no negatives, because when you do your list of numbers, I'm just going to again pull up some old notes like here, we had this big list of numbers plus or minus. So we were guessing positives, we were guessing negatives, we were guessing all kinds of stuff. Now, if you do your plus minus eye chart and none of them are negative, you've just cut this list in half, because you're no longer guessing the negatives. You're only going to guess positive 1, 2, 3, 5, 6, 10, 15, and 30. That's why this works out nicely, because if you end up with any zeros here, then you're not going to waste your time with those numbers. Okay, we're going to try another one because this can be a little confusing. So let's move on. Let's try number 2. F of x equals 5x to the 7th minus 3x to the 4th minus 2x to the 3rd plus x squared, my goodness gracious, plus 3x minus 6. All right. I'm going to leave a little space for my f of negative x. Positive, negative, imaginary. And I'm going to count the number of sign changes here. 1, 2, 3. This is 1. There's none there. That's another one. That's 2. There's none there. And the last one is a 3. Now, I either have 3 positive or 3 minus 2 is 1. Those are my 2 scenarios. I have 3 positives and 1, or sorry, not and. I have 3 that are positive or only 1 that is positive. Okay, now I do f of negative x. And I didn't give myself very much room. So 5 negative x 7 minus 3 negative x 4 minus 2 negative x third plus negative x squared plus 3 negative x minus 6. Now you don't have to write all of that. If you can like do it in your head as you're writing it out, like you can just look up here. If I plug in that negative, I'm going to rewrite it down here. That will give me a negative 5x to the 7th. You can just do that. You can skip this middle step here. But I'm going to continue. That becomes minus 3x to the 4th plus 2x cubed plus x squared minus 3x minus 6. Now let's look at our sign changes. There's 1, none, none, 2, none. So that's a 2. Again, that's 1, 2, and that one doesn't count because it stays the same. 2 minus 2 is 0. So the number of negative solutions I have is possibly 2 that are negative or none. According to this, none are negative. Okay, this can get a little confusing because there's multiple numbers here. So what you want to think of is ignore that 1. I'm just going to put a pen to cover it. So I either have 3 positive and 2 negative, or 3 positive and no negatives. According to this, 3, 2 or 3, 0. Now remember, my degree is 7, so I need a total of 7 solutions. 3 plus 2 is 5. How many imaginaries would I have? I'm actually going to cover that 0 as well. 3 plus 2 is 5. That means I need 2 more to make a total of 7. So one scenario is all 3, not all 3. 3 are positive, 2 are negative, and 2 are imaginary. 3, 4, 5, 6, 7. So if you were doing what we did earlier, that's plus, minus, I'm going to put an I, 3, 2, 2. That's one scenario. Okay. Another one is, I'm going to cover that too. 3 are positive and none of them are negative. So 3 plus 0 is 3, plus 4 is 7. 3, 0, 4. 3, 0, 4. Now notice on both of these they add up to 7. 3 plus 2 plus 2. 3 plus 0 plus 4. So first one, 2 are positive, 2 are negative, 3 are positive, 2 are negative, and 2 are imaginary, a total of 7 solutions. The second scenario is 3 are positive, none are negative, and 4 are imaginary. Okay, we still have another one to get through. We have, what if there's only 1 positive? So we're looking at 1 positive with the 2. 1, 2. 1 plus 2 is 3. 3 plus what is 7? That's another 4. I already have it there, so I'm not going to write it again. 1 plus 2 plus 4. That's 1. 2 is 3. Plus 4 is 7. Or 1 plus 0 is 1. Plus 6 is 7. 1, 0, 6. If this feels overwhelming and confusing, just keep in mind we're going to do more of these in class together. But these are my 4 possibilities. 3 are positive, 2 are negative, 2 are imaginary. 3 are positive, none are negative, 4 are imaginary. 1 is positive, 2 are negative, 4 are imaginary. 1 is positive, none are negative, and 6 is imaginary. Notice my imaginary solutions here are always even, 2, 4, 4, 6. If you end up with an odd number there, something went wrong. Okay, so we're not going to make guesses on these numbers here, but if you did have your plus minus chart that I keep referring back to over here, if you had this chart, my bet, I mean, there is a possibility that you have 2 negative solutions, but there's also a possibility that you have no negative solutions. So since that is one of the scenarios, I would go straight to guessing positives and then only trying the negatives at the end if needed. Again, when you have a scenario like this and there's possibly no negatives, I would start off guessing the positives. Okay, part 2. Upper and lower bound. Okay, now you're never going to go out hunting and looking for upper and lower bounds. They're either going to ask you on the homework to prove this is an upper bound or prove this is a lower bound, and I'm going to show you how to do that now. Or on the test, they will tell you, hint, this is an upper bound, or hint, this is a lower bound. Okay, so here's what you do. I'm just going to make up numbers. I'm going to give you a 2 and 2, negative 3, 1, 3, negative 10. I don't have that function up there. I'm just making up a set of numbers. So let's say I had this set of numbers and I'm trying to prove that 2 is an upper bound. What you do is you do your synthetic. 2 times 2 is 4, negative 3 plus 4 is 1, 2 times 1 is 2, 2 plus 1 is 3. Multiply, you get 6. Add, you get 9. Multiply, you get 18, and that is positive 8. Okay, so if they're asking you to prove on the classwork that we're going to be doing, if they ask you to prove 2 is an upper bound of this function, you get these numbers from your function, you do all this, as long as all of these numbers here come out to be positive, the row is all positive, then 2 is an upper bound. All right, what does that mean for a number to be an upper bound? I'm going to go back to that list again. Let's say we had all of these numbers here. If 2 is an upper bound, that means you can cross out positive 3, positive 5, positive 6, positive 10, positive 15, and positive 30. There's no way those are going to work. So if they give you a hint on the test, hint, 2 is an upper bound, you're going to cross out all the positive numbers that are bigger than 2. I'm going to repeat that. If they give you a hint on the test and they say, hey, 2 is an upper bound, that means you can, from your list of numbers, you can, the list of numbers like this, you can cross out all the positive numbers that are bigger than 2. Because 2 is an upper bound, there's no number bigger than that that will work. Again, you're not out hunting for them. They're either going to give them to you or you're proving it. Or if you accidentally find one, hey, good for you, then it just makes your guessing a little easier. Okay, what does it look like for a lower bound? So let's say they give you a number. It doesn't have to be negative, it could be positive. I'm just going to make up a list of numbers. 5, 12, negative 8, 1, negative 2. Positive 5, you multiply, you get negative 15. Add, you get negative 3. Multiply, 9. Add is 1. Multiply is negative 3. Add is negative 2. Multiply 6, and that gives you 4. Now notice they're not all the same. They are all not negative. What do you notice here? The signs are alternating. So if the row alternates signs, then whatever number is in here is your lower bound. All right, so again, I'm going to pull that list back up here. That means if you had the list here, you could erase, you wouldn't even bother your time with negative 5, negative 6, negative 10, negative 15, or negative 30. Okay, so it does save you time when they give you hints of upper and lower bounds on your assignment in class. They're going to ask you to prove. This is how you would do it. Put the number in there that they give you, get these numbers from your function, you do it. If they're all positive, then you've proved it's an upper bound. If they alternate signs, then you've proved it's a lower bound. Again, you're never really out hunting for them. They're either going to have you prove it or they're going to give it to you as a bonus, as a make things easier type of problem. All right. Last piece. Part A, we're going to use everything now. Use Descartes' rule of signs to get your positive, negative, imaginary possible solutions. Part B, list all possible rational roots and C, find all real zeros. Okay. Here we go. F of x equals negative 2x to the fourth plus 13x to the third not squared, 13x to the third minus 21x squared plus 2x plus 8. Okay. Just going to make it a little bit easier. I'm just going to put plus minus I. Positive, negative, imaginaries. That's part A. Use Descartes' rule of signs to figure out your possible positive, negatives, and imaginaries. Okay, so number of sign changes here. There's 1, 2, 3, and that one doesn't count, so it's 3. 3 minus 2 is 1, and I cannot subtract 2 anymore because I ended up negative. Okay, f of negative x, we'll try this one without plugging it in. That negative to the fourth is going to become positive, leaving the 2 negative. That negative to the third is going to make that negative. That is going to stay negative. That one's going to become negative, negative 2x, and then plus 8 is going to stay plus 8. Do you see that? All right, if you don't like it this way, then actually plug it in. Negative x to the fourth, negative x to the third, negative x, and simplify. There are no sign changes until the very end, so there's only 1. And 1 minus 2 would make a negative, so I'm not going to do it. Okay. 3 plus 1, my degree is 4. So if all 3 are positive, no, I shouldn't say all 3. If 3 are positive and 1 is negative, that's all 4 solutions. That means none are imaginary. That's one scenario. The other one is only 1 is positive, still only 1 is negative. That's a total of 2. I need 2 more to make the degree of 4, so that is 2. 3, 1, 0, or 1, 0, 2. For part A, if you leave your answer like this, that's perfectly fine. You can write it the way we did earlier. Plus, minus, I. What was it? 3, 1, 0. 3 positive, 1 negative, 0 imaginary. That adds up to 4. Or 1, 0, 2. 1, 0. That's not a 0. 1, 1, 2. 1, 1, 2. Again, it adds up to 4. So you don't have to do both of them. I mean, you can do both of them. But you can stop here if you want to leave your answer like this or change it to this the way I showed you guys earlier. Totally up to you. Okay, that's part A. Part B, list all possible rational roots. Okay, factors of P over factors of Q. I ignore the negative. Factors of 2 are 1 and 2. Factors of my last number, 8, are 1 and 2. I'm going to put times 1, comma 2, 4, and 8. So it's all of these over 1 and then all of these over 2. So I'm going to put plus or minus. All of these over 1 will just be 1, 2, 4, and 8. 1, 2, 4, 8 over 1 is 1, 2, 4, 8, comma, all of these over 2. 1 over 2, 2 over 2, 4 over 2, and 8 over 2. And I'm just going to reduce and eliminate if I can. Okay, 1/2 is 1/2. I don't have that number. 2 over 2 is 1, and I already have 1, so I don't have to write it again. 4 over 2 is 2. I already have it. I don't have to write it again. And 8 over 2 is 4, already there. So this is my set of possible rational roots. This is part B. Whew. And part C, find all real zeros. Okay, so what I'm going to do is go from this list here and start guessing positive 1 or negative 1, positive 2 or negative 2. They didn't give us any upper or lower bounds, so we're just going to have to start guessing. Okay, I'm going to try 1 only because I see it first and I want to work with positives. Okay, I look at my original function, not the f of negative x, this original one. 4th power, 3rd power, 2nd power, 1st power, no power, everything's there. Take your coefficients, negative 2, 13, negative 21, 2 and 8. All right, so go ahead and do that now. Negative 2, negative 2, that adds up to 11. That's 11, adds up to negative 10. Negative 10, that is negative 8. Negative 8 plus 8 is 0. Okay, we got lucky on the first try. We're happy, we're good. Okay, so remember we try to get this row down to 3. So I only have one more guess to make or to get right. So I'm going to go for my second guess. Do not start off with your original set because you're never going to get it down to 3 if you keep going back to your original. All right, now I've said before, but I haven't tried it yet. When you try a number once, there is a possibility it could work again, because that's called double roots. It could happen. Okay, I'm going to bubble this in just in case it doesn't work. I don't lose my numbers. Okay, drop it. Negative 2, negative 2, that adds up to 9. That is 9. Negative 1, negative, make sure I'm doing this right, sorry. Okay, negative 10 plus 9 is negative 1. Negative 1 times 1 is negative 1, and that does not add up to 0. So this is not a solution. So this second one does not work. Okay, so what that means is this one is a solution, but the second set, 1 is not going to work again. So 1 is only 1, it's not a multiplicity of 2. So what I'm going to do is I'm going to try again, but with these numbers here. Negative 2, that's why I bubble those in so I do not lose them. Okay, try 2. Negative 2, you can hit pause and try it on your own. Okay, so again, why did I cross this one out? Because I did not get 0 at the end. I don't go back to the original list. I go back to this one that I bubbled. That's why I bubbled it so I wouldn't lose it. Negative 2, 11, negative 10, negative 8. Negative 2, that multiplies to negative 4, adds up to 7, multiplies to 14, that adds up to 4, multiplies to 8, and that is 0. We're happy because now we don't have to continue going. So 1 is a solution, 2 is a solution, and now I make this negative 2x squared plus 7x plus 4 to find my remaining solutions. Because part C says find all real zeros. I found 2 of them, and I'm going to find the other 2 right here, and there is a total of 4 because my degree is 4. All right. Again, some might be imaginary. We don't know that yet. So I'm going to put this over here. Negative 2x squared plus 7x plus 4 equals 0, because I'm looking for my zeros. I'm going to divide everything by a negative. You could factor out a negative. It doesn't matter how you do it. I'm just going to divide it because it equals 0. 2x squared minus 7x minus 4 equals 0. If you factored out the negative 1, it would work out the same way. Or you can move everything to the other side. Add your 2x squared, subtract your 7x, subtract your 4. You'd end up with this. Double bubble, 2x and x, 1 and 4, plus and minus, negative 8, positive 1, it works. X equals negative 1/2 and positive 4. Whew. All right. Part C was list all of the zeros. We got 1, comma 2, comma negative 1/2, and 4. Those are your 4 solutions. So what did we end up with? We ended up with 3 positives and 1 negative. That was one of our scenarios. 3 are positive, 1 is negative, and there are no imaginaries. 3 are positive, 1 is negative, and we did not end up with any imaginaries. Hope this makes sense. Please come to class prepared with questions.